All right, here's our video today. Stardust inside us. So we're all made of stardust. Well, not 100%. So before the Earth was born, some 4.6 billion years ago, and even further back in time, all the elements that make us, from oxygen to iron, was made inside a star, except for hydrogen. So hydrogen makes up 9.5% of our body. It is the most abundant element in the universe, and it was the first one made. It's the lightest element, and by far it's the most abundant in the universe. Over 70% of our universe is hydrogen. But we didn't get hydrogen inside us, and we need hydrogen inside us, by the way. We didn't get hydrogen from stars. We got it from the Big Bang. So let's get the pen ready. So we can say that we're about 90.5% stardust. And the rest, that's that hydrogen, came from the Big Bang. So, like I said, the oxygen inside us, the iron inside us. Let's get a clean page and show those percentages. All right. So, the most abundant element in our body is oxygen. And that's about 65% of our body. And then we have carbon. That's about 18%, a little more, say 18.5%. And then we have hydrogen. And after hydrogen, and hydrogen is 9.5%, after hydrogen, we have trace elements. Well, we do have nitrogen, gets smaller and smaller after that, like 3.2%. We have calcium, we have phosphorus, and then it gets smaller and smaller. We even have gold inside of us. We have iron inside of us. We have uranium inside of us, potassium, sulfur, sodium, chlorine, magnesium. So all these elements, except for hydrogen, let's change that color right there, except for our friend hydrogen, came from stars. And if you know the macronutrients, like proteins and lipids and carbohydrates and deoxyribonucleic acid, DNA, all of them will have oxygen, carbon, and hydrogen. We need them to live. And all these elements make us stardust, except hydrogen. So how did this happen? This happened because stars had to explode. Stars had to go supernova. Our sun will not go supernova. It's too small. It's it's a yellow dwarf. It'll become a red dwarf in the future, maybe 5 billion years from now, and then eventually a white dwarf. But it's not massive. It's not massive enough to go supernova. We have let's get a picture of that here. So when stars go supernova, like this one over here is just an artist's rendition of one 1604. This one was seen with the naked eye in 1604, and this was 20. There was a supernova that was 20,000 light years away, and Kepler noticed it with the naked eye. There is one close by to us. It's called, and get my pen going here. It's called IK Pegasi, and it's 150 light years away, which is safe for us. If anything within 30 light years, that would be dangerous. That would not be a good day on Earth. 30 light years away would destroy our atmosphere and destroy life. But the good news is there's nothing that close. The closest astronomers noticed is IK Pegasi, 150 light years away. And again, light travels 186,000 miles per second. So that's pretty far away. In the universe model scale, though, that is pretty close, but it is safe for us. So we don't have to worry about it. And by the way, IK Pegasi is, some people think it's set to explode anyway. And if it did explode, if it did go supernova, uh, we would notice it in 150 years from now. But let's say 150 years ago it did, we would notice it, and it would be a nice light show to see in the night sky. And if you think about something, all the atoms in your body, all the matter in your body, all those 7 octillion atoms you have inside you occurred 13.7 billion years ago. So you may be 20 years old or 30, maybe you're 40 or 50, maybe you're 10, or maybe you're 99 or more, right? But in actuality, if you think about it, you're 13.7 billion years old. And here's our sun, our yellow dwarf G-type star sun. And right now, as we speak, our sun is fusing. It's a nuclear reactor. It's fusing hydrogen into helium as we speak. And eventually, in 5 billion years from now, it's going to run out of hydrogen. It's going to expand into a red giant, and it will fuse helium into carbon. And like I said before, it's too small to go supernova. But again, it's going to run out of hydrogen, and it will expand into a red giant, destroy the Earth in the process. And that helium fusing into carbon, carbon 12, but it won't fuse carbon 12 into any other elements. It's just not massive enough. So let's show a list of how that fusion takes place. And so you see hydrogen on top, helium, carbon, neon, oxygen, silicon, and eventually iron. Iron is the last stop for stars. Once a star gets into the iron phase, where the silicon fused into iron, it will not fuse anymore. So it just doesn't have enough energy. A star will have not enough energy to fuse iron into heavier elements. So what would happen there is the core will collapse, gravity takes over, and there's a massive supernova explosion. And we needed this to happen so we could be here. Let's go back to that supernova explosion. So what this is called nucleosynthesis. Oh, let's write it down there. Maybe we'll use green. See if green comes out. So this explosion, this supernova, nucleosynthesis. So all the elements I named, from oxygen to iron, well, that's made inside stars. But to get those heavier elements like gold and uranium, you need a supernova to explode. And by the way, this cosmic dust, this micrometeorites that carry these elements are still happening today. It's still entering the Earth's atmosphere as we speak today. And if you're wondering how powerful a supernova is, just think of an octillion amount of nuclear bombs. Think about the atoms inside you. Remember I said you had 7 octillion atoms. Well, let's just write it out. That's 7,000, that's 7 million, and that's 7 billion, and that's 7 trillion, and that's 7 quadrillion, and this is quintillion and sextillion and septillion, octillion. 7 octillion atoms. Well, think of an octillion amount of nuclear bombs going off. That's what a supernova explosion will be like. And if it's close, if it's anywhere within 30 light years, it will destroy life on Earth. But we don't have to worry about that. Like I said, the nearest one is 150 light years away. So we are made of stardust. Not completely, though, because remember, hydrogen was made during the Big Bang. All right, that's our video today.